In this video, a teacher is exploring how a kinesthetic approach can be used to help students develop their understanding. In this case, in working with quadratics at GCSE. In this first session, the teacher is introducing some simple materials which are used here to deepen their understanding of algebraic expressions and multiplication. The materials are designed to build on the idea of representing multiplication as an array and the grid method, with which students would be familiar.
We've got some squares, some rectangles and some little squares.
Each group has a set of tiles. Students will later explore how different combinations of these can be used to represent different expressions. First, though, to become familiar with the tiles themselves and the significance of their areas.
If I say that the longer length is x and that the shorter length is 1, talk to the person next to you, just tell each other what the areas are.
X squared, x, 1.
What are the 3 areas that we're looking at?
Is the first one x squared?
Okay.
And then the second one x.
It is, yeah.
And then the third one 1.
Okay, and the third one is 1. If you've got a rectangle whose height is x plus 2 and whose width is x plus 1, use those shapes to fill that rectangle.
So, I don't know, how would you arrange that?
X plus 1 is there. So like that. And then do you fill it?
Yeah, like that.
By working in pairs, 2 students work with one set of cards. The teacher hopes this will encourage them to discuss and explain their reasoning.
This square is x squared, so then that'll be x, and then plus 2, and then if we go across, that'll be x and then plus 1. So we've just put these here to fill it up.
That's the 3x and that's x squared.
Working together also allows students to discover different approaches and different solutions.
And then from there,
Add them all.
Drawing the whole class together, the teacher shares and confirms students' findings.
What's the total area of that rectangle?
x squared plus 3x plus 2.
Yeah, good. Start the other way round now.
Next, to specify a set of tiles that students must use to make rectangles.
What rectangle can you make?
But then,
But then where would these go in the other 3?
yeah.
And then if you use a 4 below,
Yeah,
and then
you
you put the 3 would slot in.
3 are able to slot in there.
Is that? Yeah, we've used them all.
So we put 2 there, and then we thought we could put 1 there. So then there's space for 2 there, and we still had 2 left over, so that they both fitted there.
Is there any other way we can do this? To try and like work out the area maybe? Okay, what do you think we should do?
Yeah,
Because that's like x plus 1. So like x plus 3 we'll probably have to try and get x plus 3, x plus 3, we'll probably have to try and find an area. It's got the same area each time.
These are all the area that we were given, and 3 different rectangles, but are they different rectangles is what I'm asking?
No, they're all the same. They've got the same area.
They've got the same area, yeah. What else is the same? The shape is the same. What about the actual dimensions of the rectangle?
Oh, that's x plus 1.
Right.
And then that's 3 plus x.
Yeah.
And this is x plus 1.
Yeah.
3 plus x.
Can you tell us what you guys came up with to do with the rectangle?
The length and width were always the same. It was x plus 1 and x plus 3.
As Alex said, it had to have dimensions of x plus 3 on one of them and x plus 1 on the other.
Now to use the tiles to make rectangles for given expressions.
So I'll put some questions on the big screen and then have a little go. So we use these tiles to try and represent in a concrete way the multiplication that we were doing. So for example, if I was multiplying x plus 1 times x plus 3, it's this sort of representation that I wanted the students to be getting out of it.
That's x plus 1. That's x plus 1. You need to make x plus 2 to put the extra 1 on the end.
One of the benefits for the students in having the tiles in front of them is that they have this concrete representation. They're not trying to just multiply x's by x's or x's by numbers. What they have instead is these areas that they're fitting together and that they're using as areas rather than as algebraic terms.
And it was quite hard sometimes because like your brain would be quite confused about how you'd have to move the different shapes around. But then I think when you first did it at the start, it was quite hard, but then you get into the routine and you sort of get a bit easier along the way.
We ended up trying to make a rectangle whose area was x squared plus 7x plus 12. What was its dimensions?
X plus 3, X plus 4.
Yeah, good. X plus 3 and x plus 4. One problem that we didn't get onto was representing negative numbers. What I would have said to the pupils would have been, right, we've got these the blue tiles to represent positive quantities, and white, which was the reverse side, would represent negative quantities. So if I'm trying to represent a multiplication of x plus 2 times x minus 1, then what I've got is I'll have x plus 2 here, and then I'll put minus 1 onto here. I'll put a length of minus 1 on. I'll put this on top to represent a length of x minus 1. So there's my x, with this on top is minus 1. And then to complete the pattern, these then go here on top. So these will go white on top here. So then my total area, when I'm multiplying it out, I have x squared, and then plus 2x minus 1x, that makes plus 1x, and then minus 2. So my total answer is x squared plus 1x minus 2.